Hello grade 11, welcome in our online sessions with you Mrs. Manara of your chemistry teacher. Today we will continue chapter 18 with sections 2 that talking about the substituted hydrocarbons. And I told you before that the hydrocarbons is an organic compound that contain only carbon and hydrogen. But the substituted hydrocarbon, when we replace the hydrogen atom with another atom, so substituted hydrocarbon, we will make replace for the hydrogen with other atom, and this other atom will call it function group, and the function group is a specific group of atoms or bond, and it's responsible for the chemical reaction of that compound. So the substituted hydrocarbon, and when replace the hydrogen atom with another atom, and we called it function group. The first compound is the halogenated compounds, and the halogenated, from its name, is contain halogen, so we'll replace the hydrogen atom with halogens, and the structure will be Rx, and R is this is the hydrocarbon, and X this is a halogen, where X will be chlorine, fluorine, bromine, and iodine. And the functional group, as I told you, it will be the halogen atoms, and it has high density, and we use it in the solvents and refrigerants and some plastics. And for example, for the halogenated compound is the chlorofluorocarbon and the chloroform and dichloromethane, and this is the structure for the chlorofluorocarbon. This is chlorofluorocarbon. The second substituted hydrocarbon is the alcohols, and the alcohols has structure ROH, and this is the R. I told you R refers to the hydrocarbon, and it bond with oxygen and hydrogen atom. It's called hydroxyl group. So the function group in alcohol is called hydroxyl group. This is OH. And the properties of the alcohol, it's polar and has high melting point. We use it in solvents and mouthwash and antifreeze and disinfectants. And for example, for the alcohols, and some examples for the alcohols is methanol and ethanol and isopropanol. And the alcohol takes the NOL. This is the structure of ethanol. We have here, this is 2 carbons, so it will be eth and ethane, but we will replace the E with OL because we have here the hydroxyl group OH. Another type of substituted hydrocarbon is called carboxylic acids, and carboxylic acid has structure RCOOH, and the COH is called carboxyl group, and from its properties, it's acidic, usually water soluble, and we use it in vinegar, skincare products, and the production of soaps and detergents. For example, the acetic acid, formic acid, and citric acid, and this is the structure or the formula for formic acid. Esters, and the esters has structure of RCOOR, and R dash here is refers that we have another hydrocarbon different from the first one. So we have here 2 hydrocarbons, maybe same or maybe different. Okay, so the function group here, it will be COOR dash, and the properties of the esters is strong, aromas, and volatile. We used in the artificial flavoring and in polyester fabrics. From the examples for the esters, banana oil and ethyl butyrate, which called the pineapple flavoring. And we should know that the ester is formed from the reaction of organic acid and alcohol. And for example, this is the structure of the pineapple flavoring, and this is the acidic part, and this is the alcohol part from the 2 compounds that go to form this ester. Ether is another substituted hydrocarbons, and the structure will be ROR dash, so the oxygen in the center and 2 hydrocarbons, and the properties of the ether is mostly unreactive and insoluble in water and volatile, and it's used in the solvents for the fats and waxes. So it uses for solvents for fats and waxes. For example, the diethyl ether, and this is the structure of diethyl. We have here two ethyl group and diethyl ether because the O is referred to the ether. Aldehydes and ketones. The function group here is the carbonyl group C double bond O. But we have two structures here, the structure of aldehyde and the structure of ketone. The structure of aldehyde, we have here RCOH, but here in the ketone it will be RCOR-. So the aldehyde, we have here R with carbonyl group and hydrogen atom, but the ketone with carbonyl group and another hydrocarbon. And desiccative odors, and it uses in the solvents and flavoring and plastics. For example, acetone and formaldehyde and cinnamon and vanilla flavoring. And this is the structure of the acetone. Amines and amides. The amines and amides is two substituted hydrocarbons. The amine structure is RNH2, but the amide structure is RCONH2. The function group for amine is the amino group NH2, but in the amide is the amino group bonded to carbonyl group. So we have two groups together, amino with carbonyl, it will be CONH2. The properties of amine, it basic and like the ammonia odor, and the amide it neutral and most are solids. It uses in the solvent and filterizer like urea, trypsin and aspartame, and this is the structure for butyracine. Okay, we finished now chapter 18. Please don't forget to check the LMS and print and answer worksheet 1 and send it to me on our email address alwahaamericansciencehomework@gmail.com. Thank you for listening, grade 11. Bye bye, see you in the next session.